So welcome to day 6 of creating the Byzantix Accounting Solution. Today we're going to be connecting the backend and the front end, and we're also going to be building the rest of our auth system. So what we need to do is we need to figure out how the client and server are going to connect to each other, and we need to do this securely, we need to do it efficiently, and we need to do it in a robust manner to make sure it doesn't break. Now, it took me a while to figure out how Electron does this and how to do this safely, because we need to make sure that all data is handled in such a way that it cannot be tampered with. And after a lot of messing around, I sort of figured out how Electron works, and the way it does it is it has a renderer, which is our front end. It then calls API functions made available by the preload, which then actually call the API in the main function, which is really confusing, but it's the most secure way to do it. So I think instead of talking the drawing board, the best way to do this is going to be to jump right in. So we're getting our project fired up, we're going to get the server going, we're going to get the client going. And there is our login page, as seen before, ready to go. Now I could say I did some off-camera work, but the reality is I think I just lost the clip where I built this. Essentially we've got a login handler here, and what that does is that checks the credentials, makes sure it fits the right data shape, and then sends it off to the server. So I think the optimum pattern for this system is going to be to create handlers files, and expose the handlers, and aggregate them all in one index file. So I thought it would be a really smart idea to make the main process refresh every time I make a change. The problem is, this closes and reopens the app, which blocks off everything I'm trying to do. So a bit of a mess up there. So I'm going to be straight up. I do use AI in my code to help me generate some algorithms. And I thought for this one I'll write it out myself, that way I'm going to get a better understanding of it. So if it breaks, I know how to fix it. What I'm doing here is building an algorithm to import the handlers, make them listen, and do it really efficiently. This way I'm ensuring there's a single source of truth and that I don't have to do handlers individually, just makes it a bit cleaner. But this is what I mean. I was getting this TypeScript error saying that I couldn't pass a spread argument into my function, which makes perfect sense because my handler functions are built to take in a single argument. So this TypeScript error comes from the fact that the index doesn't really know what the handler is going to take in, or what the handler is. So if we define what the handler is, that should fix it. And now we insert it into our auth handlers list of events. Ignore the error, it's just because I forgot to export the type. There we go, problem solved. I've also removed the import because it was an AI suggestion that I didn't really need anymore. So now I'm in the preload, and what I'm doing here is I'm essentially defining what our API object is going to look like, because the preload is going to inject this into the window object of React. So I thought I'd be really smart and create a new types file in the preload. However, I then realised that wasn't smart at all, because I could just reuse the same types I used in the main process in the preload. That way I create one single source of truth. So this is now what our basic login preload looks like, and I've then gone and imported it into our actual preload so it can be injected into the window object of React. So when I do API calls, I like to have a really quick way to get a response and show that a response has happened, and the way I usually do this is with a toast component. It's just nice and quick. Now, I've created the handler to handle our login API, and I put it in a folder called IPC handlers, and the reason I've done that is because I know you can use the main process to access things like the Windows file system or other computer functions that you shouldn't be able to access from the client. This just means that the naming doesn't box me in, because I may use these IPC events for other functions that I may need. So I'm going to use TanStack query to handle my API calls, and I'm not really using it for the caching. I just like the way it handles things like loading states, success responses, error responses, things like that. So I'm going to get TanStack query set up, so we're going to copy and paste the code from the docs and insert it into our app TSX. When I do controlled API calls like this, I like to use a mutation. I think it's a bit smoother than a query. It means I can control it more easily. So this is really just going to be a bog standard mutation. We're not doing anything complicated, not doing anything special. We're just going to call the function, get the response, display what I need to display. Now, I know this returned an error, but this error is actually really good because it shows us that our render process is getting to our main process, which means the API call will fire. Before I move on, the astute among you would have noticed an error in this file here, where the type for the login schema wasn't being imported correctly. Now, this error was because the TypeScript configuration file wasn't configured to include anything from the main process, so I just fixed that quickly. So I thought I'd jump straight in with some testing, and I thought I'd console log out all the credentials. And that's when I realised that this wasn't actually a software issue. It was a software issue, but it was actually an editing issue. And the problem was that I put this code in and changed one of the parameters into the handler. It was originally passing in the whole event, and that's why it was failing. However, it was about 11 o'clock when I was editing this, and I thought it'd make more sense to show you transparency than to try and redo the whole video. So, if you're a potential client, you can see how transparent I am, because I show you all the mistakes, not just the software mistakes. So essentially, it's a clip problem, and it's a filming problem. It's not necessarily a software problem, but it's nice to show anyway because it shows the mistakes. So there is me going back in time and fixing it. So now we've sorted that out, we're getting another error. So the best thing to do is to console log it and find out what's actually happening. We're getting this really long Axios error, and it may seem intimidating at first, but it's really simple. What's happened is I've put the wrong URL in the environment variables. Really simple and really annoying. So we're just going to fix that really quickly and it should all be working. After I fix the backend URL, I then need to add myself into the database, but I haven't shown that because it's not really that complicated. And once I did that, it was all working, we're logging in fine, and then it was time to build the two-factor auth. So at the start of the video, I said that I was going to show the whole auth process, but what I realised was I'd just be repeating the same thing as I've done in this video. I'll be adding the IPC handler, I'll then be adding the preload script, and I'll then be adding the render mutation, and it'd just be the same thing like 4 times, so I didn't think it was worth doing. So what I'm going to do is I'm going to end it there. But what I'm going to do after this is I'm going to release a video that's going to show you some really interesting errors that I found later on during the auth process. And as always, I don't really care about likes and comments, but if you have any feedback or you have any ways that I can improve, please drop them below.